Before we dive into the announcement, it's important to understand what particle accelerators are. The Large Hadron Collider, LHC, operated by CERN, is a 17M ring of superconducting magnets and the world's largest and most powerful particle accelerator. It represents the pinnacle of human scientific achievement. In fact, it's so powerful that it can recreate the very conditions of the universe's birth. CERN, founded in 1954, is one of the world's most prestigious research organizations. With 23 member states and thousands of scientists, it's a hub for collaboration and innovation. The LHC is CERN's flagship project, but it's just one part of a vast network of accelerators and experiments. Imagine a racetrack, not for cars or horses, but for subatomic particles in a race against time and space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy of the universe at the time of the Big Bang. The collisions create temperatures 1,000,000 times hotter than the core of the Sun. Thousands of magnets guide the protons on their journey, while intricate cooling systems keep the magnets at temperatures colder than outer space. The beams inside the LHC are made to collide at 4 locations around the accelerator ring, corresponding to the positions of 4 particle detectors: Atlas, CMS Alice, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together they act as colossal cameras, capturing snapshots of these collisions. Scientists then sift through the debris, looking for signs of the elusive Higgs boson, also known as the God particle, and other phenomena that offer clues to the universe's fundamental building blocks. By studying the microcosm, we gain insights into the macrocosm. But with every answer comes a new question, and with every discovery a new challenge. The LHC is not just a scientific instrument, it's a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. Yet, as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of probing the unknown? Could our quest for understanding inadvertently unlock forces we cannot control? In the hallowed halls of CERN, where the boundaries of human understanding are constantly pushed, a revelation has emerged that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a voice of authority in the world of particle physics, has recently made an announcement that has left the world both fascinated and fearful. Cox's words resonate with haunting clarity. The physicist went on to explain the implications of this goal, highlighting the LHC's extraordinary potential for making new discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine holding the power of creation in your hands, the ability to conjure the very essence of the universe. It's a tantalizing prospect, but one fraught with danger. The mini Big Bang is not just a theoretical concept, it's a tangible reality within the LHC. The temperatures, the pressures, the raw energy, these all mimic the conditions of the universe's infancy. It's like standing at the dawn of time, witnessing the birth of existence itself. But with such power comes responsibility, and the question looms: what if something goes wrong? Russian physicist Anatoly Bugorsky experienced a disaster that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High Energy Physics in Protvino, Russia, a malfunction led to his head accidentally coming into the direct path of a proton beam. The beam, with a force that defies comprehension, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was otherworldly. He saw a flash brighter than 1,000 suns but felt no pain. The beam's path left a trail of destruction, burning through tissue and bone. Yet he remained conscious and even walked to the clinic for treatment. The aftermath was both horrifying and fascinating. The beam's path caused localized tissue death, leading to the loss of hearing in one ear and partial facial paralysis. Yet astonishingly, Bugorsky's intellectual capabilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy, but a cautionary tale that underscores the immense power and potential danger of particle accelerators. The risks of a particle accelerator like the LHC are not to be taken lightly. The potential for unforeseen reactions, the very fabric of space and time being manipulated, these are not the stuff of science fiction but real concerns voiced by some in the scientific community. One of the most alarming and captivating concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, enigmatic entities that lurk in the shadows of our universe. The idea that the LHC could create such an entity even on a microscopic scale is shocking to both the general public and experts alike. Could this black hole grow uncontrollably, swallowing the Earth from within? Though scientists at CERN have assured that any black hole created would be unstable and evaporate almost instantly, the mere possibility has ignited debates, fears, and a sense of awe at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the fundamental mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy released is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight and then a heavy weight is dropped onto it. The fabric bends and curves. If the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. That's a simplistic metaphor for what could happen in the LHC. In the world of quantum physics, where the rules of the universe are both bizarre and beautiful, there exists a theory that extra dimensions may be hidden within our reality. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational funnel that forms a microscopic black hole. This enigmatic dance of particles has even caught the attention of some world-famous scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic vacuum decay, a cosmic event that would not only destroy the Earth but the entire universe itself. The esteemed British cosmologist and astrophysicist Sir Martin Rees also expressed his concerns about the experiments conducted at CERN. In his book On the Future Prospects for Humanity, he explored the potential risks associated with particle accelerator experiments, including those at CERN. His words were not merely cautionary, they were tinged with a sense of existential dread. He spoke of a worst-case scenario where an ill-fated experiment could create a condition called vacuum instability. This instability could in theory trigger a phase transition that would ripple through the very fabric of spacetime, resulting in a cosmic catastrophe that could engulf the entire universe. Rees' concerns were not limited to theoretical musings. He assigned a probability to these catastrophic outcomes, albeit a low one. But even a minuscule chance, he argued, should give us pause. The stakes are unimaginably high and the margin for error is razor-thin. As we move forward in our exploration of the Large Hadron Collider and its profound implications, we must also consider the broader impact of this scientific endeavor on society, technology, and the very fabric of our reality. The LHC is not merely a machine designed to answer theoretical questions, it is a symbol of human ambition, curiosity, and the relentless pursuit of understanding. One of the most striking aspects of the LHC is its potential to unlock the secrets of dark matter. Dark matter, a mysterious substance that comprises a significant portion of the universe's mass, has eluded direct detection for decades. Scientists theorize that dark matter interacts with the known universe through gravity but does not emit, absorb, or reflect light, making it nearly impossible to observe directly. The LHC, through high-energy collisions, might generate conditions where dark matter particles could briefly appear, offering crucial insights into one of the biggest mysteries of modern physics. But what if our pursuit of knowledge leads to unintended consequences? The potential to manipulate the fundamental building blocks of the universe is both exhilarating and terrifying. Could our experiments inadvertently trigger events beyond our control? Some critics argue that while theoretical models predict safety, the very nature of these experiments, pushing into realms never before explored, means there is always a level of uncertainty. Another profound question arises: could the LHC's experiments provide evidence of parallel universes or extra dimensions? String theory and other advanced physics models suggest the possibility of hidden dimensions intertwined with our own. If these dimensions exist, the energy from proton collisions in the LHC could potentially create minuscule gateways, fleeting windows into realities beyond our perception. While this idea is largely theoretical, it continues to fuel both scientific speculation and popular imagination. Beyond the realm of physics, the ethical and philosophical questions surrounding the LHC's research demand careful consideration. Should humanity pursue knowledge for its own sake, regardless of potential risks? Throughout history, scientific advancements have often come with unintended consequences. Nuclear energy, artificial intelligence, and genetic engineering all serve as examples of powerful discoveries that have raised profound ethical dilemmas. The same caution should be applied to the research conducted at CERN.